Hi everyone, welcome back. In this video, I will discuss the solution to the problem find the sum of last n nodes of the linked list. And in this problem, basically you will be given a head of a single linked list and you need to calculate the sum of last n nodes of the linked list. And here it is guaranteed that the value of n is always less than the number of node. So let's see how we can solve this problem. But before that, let's just quickly look at this sample input. So for this linked list and the value of n as 3, the expected output here is 17, as the sum of last 3 nodes is 17, 3 plus 4 plus 10. So let's see how we can solve this problem. So we can break this entire problem into a two-step. In the first step, I will count the number of node in the linked list and the sum of all the nodes. And once I get this information, let's say we have the count of all the nodes of the linked list in a variable count, which has been initialized with 0, and we also have the sum of all the nodes of the linked list, and let's say it is also initialized with 0. And this first step, that is we can find the value of count and sum in just a single while loop. So for this thing, what I can do, I can use a variable current, and we can initialize this current with head, that is the first node of the linked list. And then I will just simply increment the value of count and add the value of current node in a variable sum, and then take me to the next node. So after the first iteration, I will update the value of current as current arrow next, so that is to the node 9, and then to node 6, then to node 3, then 4 and 10. So in this way I can find the sum of all the nodes and the number of nodes. So let me just write a pseudocode for this. So current, which is initialized with head, and while the value of current not equals to null, that is to the last node. And then I will just simply add the value of current node in my variable sum. So current arrow data, and then count plus plus, since we got one node, so the number of nodes increased by 1, and then take me to the next node. Current is equal to current arrow next. So this is the first step, and once you get the sum of all the nodes and the number of node, then you can just simply subtract the sum of first count minus n node to get the sum of last n node. So my answer is simply equals to sum, that is the sum of all the nodes, minus sum of, do not get confused, this sum and this sum, or I can say that is let's say that is total. So total of first count minus n nodes, count minus n node. This will be my answer. So here the value of count, which is equals to 6, and the value of count minus n, 6 minus 3, which is equals to 3. So if I have this the sum of all the nodes of the linked list, and if I subtract the sum of first 3 node, that is this sum, then I will just simply get the sum of last n node, which is our requirement. I will just simply get the sum of last 3 node. Cool. And let me write a pseudocode for this. So this is very simple. Just simply initialize the current with again head, and run a loop for count minus n time. So for I is equals to 1, and to count minus n time, and from the sum subtract the value of current node. So sum minus equals to current arrow data, and then take me to the next node. So current is equals to current arrow next. Cool. And then your variable sum is storing the answer, that is sum of last n node. So return this variable sum. Cool. And what will be the time complexity? So the first while loop will run for number of node in the linked list time. So number of node, this is for the first while loop. And in the worst case, this for loop will run for number of nodes minus 1 times, because in the worst case the value of n is 1. So this loop will run for number of nodes minus 1 time. So eventually I can say its total equals to 2 multiplied by number of node. Our exact value would be minus 1, but since we can ignore the constant in a big O notation, so 2 into number of node, which is a linear. And since we have not used any extra space, array string or something, so the extra space, that is a space complexity, would be constant. So this is the complete solution. Let me just show you the implementation here. So here is my variable sum, then variable current and count, that will store the number of node. And this is the first step, while current are not equals to null, adding the current value in a variable sum, then take me to the next node, and also I will increment the number of node. Then this is the second step where I will subtract the value of first count minus n nodes. So initialize current with head. Then run a loop for count minus n times and subtract the value of node and then take me to the next node. And then after I will just simply return my variable sum that will store the sum of last n node. So yeah, this is the complete solution. And thank you so much guys for watching this video, and have a good day. So successfully submitted.